In the space of science and gigantic privileged insights, the subject of what existed ahead of time before the huge impact has blended conversations and intrigued characters for quite a while. This Goliath request doesn't just test how we could disentangle the universe, it challenges the genuine farthest imperatives of human data. Imagine standing at the edge of existence, examining the gigantic shadowing, and taking into account what lay there before our universe was imagined. The event of the Big Bang marked the beginning of history, space, and what we know. In any event, there was a moment sooner. In advance, this may have eventually been a condition of nothingness, a calm before the bombastic gathering began. Assuming this is legitimate, was it, or perhaps there was something significantly more upsetting that existed before time itself? As we dive further into this request, science takes us on a journey past the universe's beginning stage into thoughts that challenge our mindfulness. Physicist Brian Cox, known for his commitment to the wonders of the universe, suggests that something shocking might have existed before the Big Bang. He moves us to rethink our understanding of the genuine world and existence. In this evaluation, we'll dismantle the science, the speculation, and the astounding insider secrets that might help us sort out what existed before everything. We'll explore contemplations like godly improvement, quantum changes, dark energy, and even multiverse. The reactions we've covered might just stifle you, but they could also open new understandings of our circumstance in the universe. Plan to jump deep into a world beyond imagination and science, where the dark still weaves through the shadows, leaving scientists shocked and sometimes even unsettled. We ought to examine what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what could have existed before the Big Bang, we first need to look at what the Big Bang was. The Big Bang was a scientific fact. It refers to the event when the universe became extraordinarily hot and dense, expanding rapidly to set off the formation of all matter, energy, and boundless forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading out from a starting point. At any rate, for what reason did this occur? Was there a time before this dense, hot start? According to the theory of cosmic inflation, there was, without a doubt, a before, and it was far from void or quiet. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, vacant, and free, fundamentally like an epic vacuum. However, this vacuum was not entirely empty. It contained a massive amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so rapidly that it generally set the stage for all that would continue. In an ongoing moment, space expanded at unbelievable rates until the expansion slowed down, and the energy transformed into matter, particles, and the forces we associate with the Big Bang. But what was the nature of this energy? Why did it suddenly foster the universe? And for what reason did it stop? Scientists believe that this boundless expansion created patches of the universe, each experiencing its own Big Bang. Imagine a material expanding continuously, with minuscule air bubbles forming. Each bubble represents a universe, including our own. This thought, called the inflationary multiverse, suggests that there are potentially unfathomable Big Bangs and a boundless number of universes. Our own is only one of many. This tremendous, mind-bending reality challenges our understanding of the very nature of the universe itself and leaves us with the question, what else is out there? The concept of nothingness before the Big Bang is theoretical, not real. At any rate, according to our current understanding, even if you remove all energy, particles, and radiation from the universe, it would still not be genuinely void. Our universe is filled with dark matter, dark energy, quantum fields, and various forces that create a woven masterpiece of existence. Even in its most stripped-down form, the universe is never truly empty. Regardless of whether we imaginatively strip away these forces, leaving a dead space, the universe would still create new kinds of energy. This baffling reality suggests that true nothingness may be unfathomable. Space itself has properties, rules, and constants that prevent it from being completely empty. Imagine creating a region with literally nothing in it, no particles, no radiation, and no energy. Yet, quantum fields and fundamental constants would still exist, suggesting that this nothingness has properties. For instance, there's a concept called zero-point energy, which represents the lowest energy state of quantum fields. Even in this state, particles can still appear and disappear, creating a faint resonance of activity, even in what should be empty space. This challenges our notion of a true void and suggests that, yes, even before the Big Bang, there was something. Analysts are still beginning to appreciate one of the most astonishing speculations in modern cosmology, the possibility of undying development. If inflation could create our universe, it's possible that it could continue perpetually. Brian Cox describes an extraordinarily colossal inflationary multiverse where universes are unimaginably created and expanded. Imagine each Big Bang as a spark lighting another universe while inflation occurs in different regions, creating innumerable other universes. This cycle, in theory, could happen forever. This idea of colossal universes giving rise to others leads to a fascinating thought: a fractal universe, where each new universe may, in fact, create its own Big Bang. Every universe exists as an alternate, independent space, unaffected by the others. Considering the rapid expansion of space, researchers find this hypothesis both exciting and unsettling, as it suggests an endless multiverse with no clear beginning or end. Imagine our universe being just a tiny fragment in a vast, boundless structure, constantly developing and always creating new universes. And what if that's the true nature of reality? What if there is no before or after, but rather an eternal cycle of universes forming? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe isn't just a mix of matter floating in space. Rather, it's a complex network of energy fields that fill the cosmos, working together to create what we observe. These fields act like intangible seas, with particles behaving as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can briefly appear and vanish, obtaining energy before returning it. These fleeting particles, called virtual particles, challenge the plausibility of true emptiness. Imagine an empty universe where all matter, energy, and radiation have been removed. Would you truly have nothing? According to quantum field theory, you wouldn't. Even in a vacuum, fields remain dynamic, sometimes creating transient particles. This constant activity in what should be nothing suggests that the universe does not adhere to our traditional concept of emptiness. Another theory, cyclic cosmology, offers an alternative to the Big Bang as a definitive beginning. This theory suggests that the universe undergoes immense cycles of birth, death, and renewal. In this model, the Big Bang is not a one-time event but rather part of an eternal cycle where universes expand, contract, and then give rise to new universes. According to this idea, our universe could have been reborn from the remnants of a past universe. The process of compression and expansion in a repeating pattern would mean that there was never a true beginning, just an infinite sequence of universes forming and dissolving over and over again. Cyclic cosmology raises profound questions about the nature of time itself. Instead of moving in a straight line from past to future, time might follow a looping pattern, repeating endlessly. If this theory is correct, then what existed before the Big Bang was simply another form of the universe, going through one of its many transformations. This perspective fundamentally changes how we perceive reality. Instead of a singular moment of creation, the universe could be in a continuous cycle of rebirth, where each end marks the beginning of another. But how does this cycle work? Some physicists propose that dark energy, the mysterious force driving the universe's accelerated expansion, might eventually weaken. If that happens, gravity could take over, pulling everything back together in what's known as the Big Crunch, a reversal of the Big Bang. This could lead to a new singularity, which would then trigger another explosion, starting the next cycle. Other versions of cyclic cosmology suggest that instead of collapsing, the universe might transition into a new phase, allowing a fresh universe to emerge from its decayed state. These ideas push the boundaries of our understanding of space, time, and existence itself. They suggest that rather than seeking a first moment of creation, we should instead consider the universe as an eternal process, one without a clear beginning or end. Could our universe be one of many? The notion of a multiverse has gained significant traction in modern cosmology. If our universe was born from an inflationary process, it's possible that other universes were created alongside it, or even before it. This idea suggests that the Big Bang wasn't unique. Instead, space might be an ever-expanding cosmic fabric where new universes constantly form in different regions, each with its own laws of physics and conditions. In some versions of this theory, every Big Bang represents a separate universe, forming like bubbles in an endless cosmic sea. Some of these universes might be similar to ours, while others could be vastly different, governed by entirely different physical laws. If the multiverse theory is true, then the question of what existed before the Big Bang becomes even more complex. Rather than looking for a singular answer, we might have to accept that our universe is just one chapter in an infinite cosmic narrative, one of countless universes, each with its own beginning and history. The role of quantum mechanics. Another approach to understanding what came before the Big Bang involves quantum mechanics. Quantum physics suggests that, at the smallest scales, particles can appear and disappear seemingly at random. These quantum fluctuations could have played a role in the birth of the universe. Some scientists propose that the universe itself may have emerged from a quantum fluctuation in a vacuum, a sudden, random event that sparked the expansion of space and time. If this is true, then the universe was not created from nothing in the traditional sense, but rather from a quantum state that allowed for its sudden emergence. This concept aligns with the idea that space itself is never truly empty. Even in the absence of matter and energy, the quantum vacuum is filled with fluctuations that could potentially give rise to new universes. The search for answers. Despite the many theories proposed, the question of what existed before the Big Bang remains one of the greatest mysteries in physics. Whether it was a previous universe, an eternal multiverse, or a quantum fluctuation, scientists continue to explore the origins of everything we know. Advancements in cosmology, quantum physics, and theoretical models may one day provide a clearer picture of our universe's true beginnings. Until then, the search for what came before the Big Bang remains a fascinating and deeply profound journey, one that challenges our understanding of time, space, and reality itself. The universe, one that fell solely to give rise to the universe we currently have. For scientists, this theory offers a rich answer to the question of extreme origins, proposing that there is no clear beginning. Since its inception, the universe has existed in some form, transcending our thoughts of time and existence. Gravitational waves are another interesting idea that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are swells in spacetime caused by incredibly massive objects such as black holes or colliding neutron stars. These waves can travel long distances, carrying information about the events that created them. Could gravitational waves provide information about the birth of the universe? A few physicists propose that gravitational waves coming from the time before the Big Bang may provide insight into the state of the universe before inflation started. Gravitational waves from the early universe might leave clues that could help us understand whether or not the Big Bang was actually the beginning, or whether there were cosmic events before it that we don't yet comprehend. These waves could be traces left behind by events beyond our usual knowledge. Their presence could also hint at a grander structure beyond what we are familiar with. These faint signals might unlock pieces of knowledge that could alter our worldview in the same way that discovering the Big Bang did. What if they show the remnants of a past universe or an incident that occurred before the Big Bang? As scientists continue to research the deep reaches of space, the question remains, what existed prior to the Big Bang? With theories pointing toward quantum mechanics, multiverse, and cosmic inflation, it seems we are closer than ever to revealing the extensive mysteries of the universe's origins. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to grow with each new discovery. As we explore these theories, we can also contemplate how they might fit together to show the bigger picture, the true nature of existence itself. But until then, we are left with the mystery, pushing science further into unknown places far beyond what we have yet known. As we continue exploring the question of what existed before the Big Bang, the idea of time itself becomes increasingly difficult to comprehend. Time, as we understand it, began with the Big Bang, making the concept of before somewhat paradoxical. If time itself did not exist prior to the Big Bang, can we even speak of something existing before it? Some theories suggest that time might not have a clear starting point and that our understanding of it might be limited by the current framework of physics. One of the fascinating aspects of these theories is that they open up the possibility of new laws of physics, ones that haven't yet been found or even imagined within our current understanding. If the universe as we know it began with the Big Bang, and before that there was a state of nothingness or cosmic inflation, then what governs the forces and particles in that pre-Big Bang state? Could there be an underlying layer of reality that transcends time and space, where the usual laws of physics break down entirely? This metaphysical layer would defy everything we understand about the universe, and yet it could hold the answers to some of the most profound inquiries. Some researchers have speculated that the beginning of the universe might not have been a singular event but instead could be the outcome of the interaction of higher dimensional forces. String theory, for example, proposes that the fundamental constituents of matter are not point-like particles but rather one-dimensional strings vibrating at different frequencies. These strings may exist in spaces with higher dimensions beyond the three-dimensional space we perceive. If this theory holds true, then our universe could be just one slice of a higher dimensional space that intersects with others, forming the multiverse. In this scenario, the Big Bang could represent the intersection of these dimensions, with a continuous cycle of universes being created and destroyed in higher dimensions. Moreover, Theories such as the ekpyrotic model propose that our universe could have resulted from a collision between two higher-dimensional brands, membranes of spacetime that exist in more than 3 dimensions. These collisions, if they occurred, could have triggered a Big Bang-like event, starting a new cycle of expansion and contraction. Such models offer a framework for understanding the origins of the universe that doesn't rely on a traditional singular beginning point but instead presents a scenario of constant rebirth through cosmic events. This idea challenges our traditional thinking about the beginning of the universe and opens up possibilities for how it might evolve in the future. There are also intriguing ties between these cosmological theories and philosophical questions about the nature of existence itself. If time, space, and matter have always existed in some form, does this imply an eternal and unchanging reality beyond our perception? Or are we in the midst of an endless cycle of creation, expansion, and destruction? Some have even proposed that the answers to these questions lie outside the domain of science entirely and may only be fully understood through metaphysical or even spiritual inquiry. This suggests that the limits of human understanding might not just be about technological advancements in physics but also about the deep existential nature of reality itself. In conclusion, while we may never fully answer the question of what existed before the Big Bang, the theories and concepts surrounding it provide a rich tapestry of possibilities. As our understanding of quantum mechanics, dark energy, and cosmology continues to develop, we may inch closer to discovering the true nature of time, existence, and the universe as a whole. Regardless of whether the answer is grounded in science, philosophy, or something entirely beyond our understanding, the mystery of what came before the Big Bang continues to captivate and inspire humanity's pursuit of knowledge. One possible explanation comes from the concept of a cyclic universe. Some theories suggest that the universe undergoes infinite cycles of expansion and contraction, with each Big Bang being the result of the previous universe collapsing. This idea, which dates back to ancient cosmological thought, has been revisited in modern physics through models like the conformal cyclic cosmology proposed by Roger Penrose. According to this theory, the end of one universe can smoothly transition into the beginning of another, with no true starting point in time. Another perspective suggests that our universe emerged from a quantum fluctuation in a larger, pre-existing structure. In quantum mechanics, fluctuations constantly occur at the smallest scales, even in what we consider empty space. Some physicists speculate that an exceptionally large quantum fluctuation could have triggered the birth of our universe, possibly within a larger multiverse. This idea aligns with the eternal inflation model, which suggests that our universe is just one bubble among countless others, each forming from quantum fluctuations in a vast, inflating space. If true, this would mean that the Big Bang was not a singular event but rather one instance in an ongoing cosmic process. Some universes could emerge, expand, and eventually fade away, while others might have entirely different laws of physics. This raises profound questions. Is there a fundamental mother universe from which all others arise? Do these other universes interact with ours in any meaningful way? Could remnants of a previous universe still exist within our own, waiting to be discovered? Interestingly, some researchers believe that echoes of a past universe could be imprinted in the cosmic microwave background, CMB, the faint radiation left over from the Big Bang. Certain anomalies in the CMB have been interpreted as possible signs of pre-Big Bang structures, though this remains a highly debated topic. The role of time and space in pre-Big Bang theories. The very notion of before the Big Bang challenges our understanding of time. In our everyday experience, time moves forward in a linear fashion. But in extreme conditions, such as those at the very beginning of the universe, time itself may behave differently or cease to exist in a conventional sense. Some theories suggest that time is emergent rather than fundamental, meaning it arises from deeper physical principles. In this view, before the Big Bang, there may not have been time as we understand it, only a timeless quantum state that eventually gave rise to our observable universe. Other proposals suggest that time is cyclical rather than linear, meaning it could loop back on itself in an endless sequence of beginnings and endings. If this were true, then the question of what came before the Big Bang would become irrelevant, as there would be no absolute beginning in a conventional sense. The limits of human understanding. While scientific theories continue to push the boundaries of what we can know about the pre-Big Bang universe, we must also acknowledge the limits of our understanding. Some aspects of this mystery may be beyond our ability to measure, test, or even fully comprehend. This brings us to the philosophical and metaphysical implications of these ideas. If the universe had no true beginning, does that mean existence is eternal? If time itself is a construct, what does that say about our perception of reality? And if the ultimate nature of the cosmos is unknowable, Does that mean science has its limits, or does it mean we must redefine what we consider knowledge? As we continue to explore these questions, new discoveries in quantum physics, cosmology, and theoretical physics may provide deeper insights. Whether through advancements in gravitational wave detection, new interpretations of cosmic background radiation, or breakthroughs in quantum gravity, each step brings us closer to understanding the origins of everything we know. For now, the mystery remains: what, if anything, existed before the Big Bang? The search for answers continues to inspire both scientific inquiry and philosophical wonder, reminding us that the universe is far more complex and fascinating than we may ever fully grasp.